So we were talking about energy a little while ago, and now we're going to talk about heat. Heat is a form of energy, and heat is measured in joules. Okay, so the units for heat will be joules. The problem is, before we start, people tend to take heat and temperature and get them confused, and they are not the same. So before we start talking about heat, let's compare heat and temperature. Okay, and I'm going to give you a couple of situations. I'm going to give you two solutions to a problem. And these are in Fahrenheit because we all understand Fahrenheit better being in the United States. You have a large tub of water and a cup of tea, hold on, at 185 degrees Fahrenheit. Now, you have just come in from a day of being on the slopes, and you are all snowy and cold and just freezing, and you want to heat up as quickly as possible. So, the cup of tea, obviously at 185 degrees, is hotter. It has a higher temperature than the large jacuzzi at 105 degrees Celsius. Which of these is going to heat all of you up more quickly? To sit in your cold clothes and drink a cup of tea, or to climb into a bathing suit, jump into a jacuzzi at 105 degrees? Okay, you're going to jump into the large, or 102, you're going to jump into the large tub of water at 102 degrees. Why is that? It's because this large tub has more heat. Heat is an extensive property. It depends upon how much of something there is, and that is the inherent difference between heat and temperature. We're going to be calculating how much heat is needed to change some various substances. So we need to talk about something called heat capacity. Okay, the amount of heat needed to raise 1 gram. Actually, that's supposed to be like 1.00 grams, but the amount of heat needed to raise 1 gram of a substance by 1 degree C is called the substance's specific heat. Okay, specific heat. Sometimes books call it specific heat capacity, but there's another term called heat capacity, so we're just going to call it specific heat. So metals have low specific heats. Water has a very high specific heat. This business about needed to raise 1 gram of a substance 1 degree Celsius sounds remarkably like the definition of a calorie, or like the definition of 4.184 joules. And those are, in fact, the specific heat of water. Okay, so we could write S for specific heat sub water equals 4.184 joules per gram degree Celsius. That many joules are needed to raise 1 gram of water 1 degree Celsius, or we could write it as 1.000 calories per gram degree Celsius. Takes that many calories of heat, 1 calorie to raise 1 gram of water 1 degree Celsius. These are all on page 71 of your text, and you can look them up online. So we're going to be using this equation quite frequently until the end of the chapter. The equation is Q equals MS delta T. Okay, Q is the heat in joules. M is the mass of the substance, and that is in grams. And delta T is T final minus T initial. Okay, it's always final minus initial. And it would be in degrees Celsius. So let's do a couple of practice problems from your book. The first one, they tell you, okay, so this is practice problem 1. You have 8 grams of water, and the water goes from 42 degrees C to 45 degrees C, and they want to know how much heat is needed. Q equals what? You would have to realize that you knew the specific heat of water, that S of water, the specific heat, is 4.184 joules per gram degrees C, and that delta T is T final, which is 45 degrees Celsius, which is what the final temperature was, minus the initial temperature, 42 degrees C, or 3 degrees Celsius. Okay, now you have everything to put into this equation. You're looking for Q, you have the mass, it's 8 grams. We have the specific heat. You can either look it up, or you would know it in the case of water, and we just calculated delta T. So we just plug in here, Q equals 8.0 grams times 4.184 joules per gram degrees C times 3 degrees C. Grams will cancel with grams here. Degrees Celsius with degrees Celsius here. We're going to multiply 8 by a little bit more than 4, then times 3. And with too many significant figures, I had 100.4 joules as the answer. So let's call it 100 joules and be done with it. The second practice problem in your book had you putting a hot piece of metal into some water and finding the specific heat of the metal. And this is a situation where you're going to find that the Q of the water is equal to the negative Q of the metal. If the water is losing heat, if the water is gaining heat, the metal is losing heat. So the information you were given was that you had 110 grams of metal, and it was initially at 55 degrees Celsius. You don't know what S is. Whoops, S is a big question mark. This is Ti, T initial. And over here we had 150 grams of water. You know the specific heat of water. It's 4.184 joules per gram degree. But this is M of water. We were told that the water went from 23 degrees Celsius to 25 degrees Celsius when you drop the hot metal in. So delta T, if you subtract those, delta T is equal to a positive 2 degrees Celsius. And S of the water is 4.184 joules per gram degree C. Okay, so we can set these two things equal to one another. What we seem to not have is the final temperature of the metal. But you're putting hot metal in cold water and the temperature is going up, and eventually it's going to equilibrate and the temperature of the metal and the temperature of the water will be the same. So T final of the metal is the same as T final of the water, which is 25 degrees C. So delta T is 25 minus 55, or 30 degrees C. Okay, so... What?
Negative 30 degrees.
Negative 30 degrees. I knew that.
Got the sign correct.
Okay. I have my producer back here taking care of everything. All right, so plugging it into the equation, I'm going to put in all the numbers I know for Q, water. I'm sorry, these are reversed. But I have 150 grams of water times 4.184. It'll work. Times delta T, which is 2 degrees. Okay, and that's going to be negative, and that is going to be equal to Q of the metal, which we don't know, but it is grams, 110 grams, times the specific heat, S sub metal, times delta T, which is negative 30 degrees Celsius. We're going to rearrange all this, so we're going to get S metal by itself. So we have this crazy thing, negative 150 times 4.184. I'm leaving the units out because right now it's getting to be way too messy, divided by 110 grams. Okay, grams are going to cancel. Divided by delta T, which is negative 30. Okay, so the degrees C are going to cancel. My negative signs are also going to cancel. And when I multiply 150 times 4.184 times 2, then divide by 110 and divide by the negative 30, I get a specific heat of 0.38 joules per gram degrees Celsius. So we're done with that. Yay.